for number 15, this is a hard one. We have the integral of 1 over x cubed plus 1. The first step is that we have to factor the denominator. The answer for this is not ln of x cubed plus 1, right? Not that. Anyways, though, let me remind you guys, when we have a cubed plus b cubed, sum of two cubes, we can get the factoring a plus b times a squared minus ab plus b squared. Now, for x cubed, it's of course just x cubed like this. For the 1, we can look at it as 1 cubed. So, we get x plus 1 times x squared minus x times 1, which is just x, and then plus 1 squared, which is just 1. So, we are just going to be integrating 1 over all that. Now, the key right here is we will have to do partial fractions. And in fact, this one is going to be quite long. I'm going to do the partial fraction right here. When we have 1 over x plus 1 times x squared minus x plus 1, this is a quadratic that does not have any real roots. So you keep it as a quadratic. Right here, we will have the first fraction with x plus 1 on the bottom, and then the next one is the quadratic. The top is always going to be 1 degree less than the bottom, so here we will have a constant, and for the second one we will have a linear. So let's put down bx plus c. Now for a, we can do cover up because the denominator is just x plus 1. We can make it equal to 0. When x plus 1 is equal to 0, that means x has to be equal to negative 1. And remember, we are going to cover up this right here. Just go ahead and plug in negative 1 into these two x's. So we get 1 over negative 1 squared minus negative 1 plus 1. Work that out, we will get a being equal to positive 1/3. Now, unfortunately, to figure out b and c, we cannot do cover up anymore. Because if you cover up the same denominator right here and the original, well, as I mentioned it, you cannot make the bottom equal to 0 with real numbers, right? Plus, once you cover it up, are you trying to solve for b or c, right? Anyways, here's how you can solve this right here real quick. Remember, this expression is supposed to be true for all x. And so far, we have used x is equal to negative 1. Let's go ahead and plug in any other x values into the expression so we can end up with an equation, and hopefully that can help us solve for b or c. Notice we have b times x, and so far we haven't used 0 yet. So 0 is a great number because b times 0 is just equal to 0. There's no b. So here, I'm going to say let x equal to 0. And then let's go ahead and plug in 0 into all these x's, including this one right here. Now, this is just 1. That's 1. 1 times 1 on the bottom. On the left-hand side is 1. Yeah. And on the right-hand side, remember this is 0. So we have just 1/3. Plus, this is 0. So we just have c over 1. So it's just c. So from here, you can get c is equal to 2/3. Very nice, huh? Now next, let's pick another x value. We used negative 1 and 0. Let's try positive 1. And hopefully it's just as easy. Let's see. On the left-hand side, we have 1 on the top over, this is 2. This is 1 squared minus 1, which is 0. But we have another 1 here. So we have 2 times 1, which is just 2. And that's equal to 1/3 divided by 2, because x is equal to 1. So that's 1 over 6. Plus, this is b times 1 now, so it's just b. And then c is equal to positive 2/3. So I'm going to just put down plus 2/3. And we're pretty lucky because when we plug in 1 into the x here and here, 1 minus 1 is 0. So this part doesn't matter. We just have to divide it by 1, which of course doesn't matter. So I'm not going to write that down. Now, from here, if you solve for b by doing the equations and all that, you can multiply this equation by 6, so you can get rid of the fractions. And I will tell you b will be negative 1/3. So that's pretty good, because now at least we know the a, b, and c. b is negative 1/3. So I'm going to go back to the previous page, and then I'm going to write this down for you guys. Here, instead of integrating this thing, we will be integrating the first one. We have the 1/3 over the first denominator, and then for this portion here though, I'm just going to write it down for now to make it clear. So we are going to add negative 1/3 for the b times x plus 2/3 for the c over the denominator right here, dx. And in fact, just to make sure I will have more space later on, I'm going to put this one right here. Now, I'm going to separate the integrals a little bit. First one, because we have a sum, so I can just integrate this and integrate that, right? And then the 1/3 is a constant multiple. I can put that in the front. And I'm going to close this integral. Next though, what I'm going to do is, notice how we have the third, right? It's a constant multiple. I'm going to factor that out. And also, because the leading term inside, we have a negative. So I'm going to factor out a negative 1/3. And we will have the integral. Take this, divide it by negative 1/3, we will just have x. Take this, divide it by negative 1/3. Positive divided by negative, we have negative. Just be careful with that. And then the 2. And then over the denominator. Okay. Now, the first one is nice and easy. But for the second integral right here, it's not so easy. How can we do it? Well, imagine for the bottom, right? Let's take a look at the bottom. We have x squared minus x plus 1. If we take the derivative of the bottom, well, we'll just get 2x minus 1, right? So, wouldn't it be nice if the top right here happens to be 2x minus 1? Sure thing, because that way we can just do a quick use up and then we'll be done, right? So, let's go ahead and make that happen. How though? Well, I'm going to multiply this by 2 so that I will have the 2 for the x. But of course, I will have to immediately divide it by that, so we will have the 1/2 right here. Okay, let's see what we have. I will still write down the first one right here for you guys. So far we haven't done any calculus yet. And then multiply these two together. And then we have the integral, and I'm going to distribute the 2 right here. So we have 2x minus 4. That's pretty good now, because at least we have the 2x. But we don't want to have 2x minus 4. We want to have 2x minus 1. So we are going to break down the minus 4. Minus 1, minus 3. Yes. So I'm going to look at this, and again, write this down. And then minus 1/6. And I'm going to separate these two integrals inside. Integral 2x minus 1. So we'll do this first. And I'm going to close that integral. And then I'm going to have, let's write it as plus integral of negative 3. And then the denominator. Like this. Whew. So far the first integral right here, easy. right? And then this right here, nice. But for the third one, we actually will have to complete the square for the bottom. Whenever you have a quadratic that's not factorable on the bottom, completing the square is the way to go. So let me just kind of quickly remind you guys how to complete the square right here for that part. So when we have x squared minus x plus 1, we're going to write it as x squared minus x. Leave a space. Here, make sure we have a coefficient of 1 in front of the x squared, which it does. So take a look at the coefficient of x, which is -1. We will have to add -1 divided by 2, and then square that. And in the same expression, subtract that. This way, the first three terms will give us a perfect square, and it will be x minus 1/2 squared, and then plus 1 minus 1/4. And that is x minus 1/2 squared plus 3/4. Now, we are going to look at this as a sum of two squares. So let's write it as x minus 1/2 squared plus square root of 3/2 squared. Because we will have to use the inverse tangent formula in order to integrate that part. So I'm going to put this down for this one. So we'll make a quick switch. We will have x minus 1/2 squared plus square root of 3/2 squared. Okay, ladies and gentlemen, let me just make a note right here real quick. Okay, I still have enough space. That's good. Note, whenever we have to integrate 1/x squared plus some number a squared, here actually, let me just do u. We will get 1/a times the inverse tangent of u/a. And here is our u. And thankfully, when we have u equal to x minus 1/2, differentiating that, du is the same as dx, so we don't have any extra constants. So let's go ahead and integrate all this now. Here we have 1/3. The first one will give us ln absolute value of x plus 1. Done. Next, let's also distribute the -1/6. So we have the minus 1/6 ln, and remember this is our u for this integral, so perhaps I'll make a note right here. And we will have x squared minus x plus 1. In fact, this is never negative, so we can just use a parenthesis for this right here. Now, remember we're distributing the -1/6. So I'm going to put this down. We have -1/6, and then we still have the -3. And then we will have the rest, right? You can look at the blue part, like the blue integral. I'm going to write this down. Here is our a. So we will first have to do 1/a, so multiply by its reciprocal. So 2/square root of 3. And then we will have the inverse tangent. U is x minus 1/2. And then over a, and I would just like to write it as 2/square root of 3 times u, which is x minus 1/2 like this. Whew, just like that. And then not done yet. I'm going to simplify this a little bit. So have a look. Firstly though, I can cancel this out. This is 1, this is 3. And then next I can cancel this and that out. That's pretty good. Yeah. Okay, I'm just going to write this down all over again. So 1/3 ln absolute value of x plus 1 minus 1/6 ln parentheses x squared minus x plus 1. And then minus times the minus. Be super careful. You get plus. And then 1/square root of 3 inverse tangent of And if you want to distribute this, go ahead. I'll do that too. And then 2 and 2 cancel, so we'll have a minus 1 over square root of 3, and then all done. Whew. How long did this take us?